Next computational method is something we call the Galley method, and it's another way to multiply two numbers together. And for this, what we do is we create an array with rows and columns. And so in this case, we see we have one row, and that's going to represent our 7 right here. And then we have 17, so we have two columns. Now it turns out it doesn't matter if you did two columns in one row or one column and two rows, we would get the same answer. And basically what we want to do now is each one of these boxes becomes a multiplication problem. So this box right here really becomes 1 times 7. Now we know 1 times 7 is 7, so I'm going to put a 0 here and 7 right here. Now in this box, we're going to do the multiplication for 7 times 7. And we know that's 49, and so we're going to put a 4 here and a 9 here. Okay, so the basic concept, we have our rows and our columns to represent the multiplication of our numbers, and in each box we separate it with a diagonal, okay, just separating the tens place from the ones place. What we do from here is we go ahead and add now along these diagonal lines right here. Okay, so in this case, along this diagonal, all we have is a 9. Here in this case, we have a 4 plus 7, and we know this is 11. So what I do is I put the 1 here, and then I carry a 1 up to this next spot right here. And so now I have 1 plus 0, which is 1. And now my final answer is going to be right here, or 119. Okay, let's try one more of those together just to make sure we get it. So here I have 3 columns and 2 rows. So I'm going to put my 3-digit number in my columns, a 3, a 1, and a 2. And then my 2-digit number I'm going to put as my 2 rows, a 7 and a 5. Now the beauty of this is all you have to do is be able to multiply any number 1 through 9 by any other number 1 through 9. So if you know your multiplication facts for the single digits, you can do all of these very easily. And it doesn't even matter what order you fill these in. For instance, I can do 1 times 7, and I know that's 0, 7. So the order of my multiplication doesn't matter. So we fill this in. We'll do 3 times 7, that's 21. 2 times 7 is 14. We can do 2 times 5, that's 10. 1 times 5, and that's 5. We just have to remember to put the 0 if it's a single digit. And then 3 times 5 is 15. Once we have all of these multiplications, now we just add along these diagonals. And then make sure to carry any groups of the base into the next diagonal. Okay? So this here gives me 0. Here 4, 1, and 5, that's 10. So I'm going to put a 0 and I'm going to carry the 1 right up here. And that's the trickiest part about this. Now we have 1 and 1 is 2, plus 7 is 9, plus 5 is 14. Put a 4 and we carry a 1. And then 1 and 0 is 1, plus 1 is 2, plus 1 is 3. And then here we just have a 2. So our final answer is 23,400. And again, feel free to check all of these with your calculator, but again, the work must be shown. All right, I want you to try example 3 on your own. So go ahead and fill these out, pause the video, and come on back when you're done to check your work. All right, welcome back. Go ahead and check your work in these boxes here, and you should have come up with 65,629. So that was the Galley method, and I find it very useful. Just a great way to organize long multiplication.